So the question here is, how do we graph given either the slope-intercept form or the standard form? The first one is basically remember that 5/2 is the slope, and that's going to be rise over run. And this -1 is going to be your y-intercept. What that means is that when you go to graph this, it's going to be crossing the y-axis at -1. And then we can count that slope, rise over run, rise 5, run 2. So rising 5 means 5 up, 2, 3, 4, 5, run 2, 1, 2. And that's going to be another point on this line. We can do it again, 1, 2, 3, 4, 5, run 2, 1, 2. And then we can draw this, use a ruler of course, and it's going to extend right through to the other quadrant. When we're doing a line that has standard form, the easiest way is to make a mini table of values. If x is 0, what's y? If y is 0, what's x? So we cover up the x, we find -5y is equal to 9, so we can divide the -5 underneath. So this is going to be 9 over -5, okay, which is -9/5. Not a nice number to work with. We'll see how to handle that a different way maybe. Then, if I want to figure out when the y is 0, this term disappears, and I'm solving for 3x equals 9, x is equal to 3. Now I plot both of these points on the axes. The x-intercept, well, I'll do the y-intercept first, -9/5. That's a little bit less than -2, so that's going to be a point right about here. And the x-intercept is at 3. 1, 2, 3. And we don't have a lot of points to test here, so a ruler is really important when we go to graph this. If you want to make this a little bit better, you can isolate the y. 3x minus 9 equals 5y. I brought this to the other side, and I divide through to find out the slope. Because now that I know the slope, 3/5, I could actually give a little bit more accuracy to my graph. I can go up 3 over 5, 1, 2, 3, 4, 5. So we can see that my line is actually off by a little bit. Should be more that way.